So January 2017, Unit 5, we'll discuss the MCQs. So which set of a successive ionization energy could not be transition? Because for transition element, what happened? The successive ionization energies are comparable. Yeah, that's right. So D is the right answer because what happened, you can see a big jump 900, 1700, then 14,000. So that's a big jump, and then 21,000. They should be comparable. Like example, if it double or but not increase drastically, that's why D is not the right answer. As for transition element, the successive ionization energies are comparable. The bonding within the complex. So within the complex, what we have, because there is, yeah, that's right, because within the complex there will be covalent bond as water molecules are there, and there will be a dative bonding between the central atom and the ligands. Then question 3, an aqueous solution of a transition metal ion form green PPT with both ammonia and sodium hydroxide. The green PPT dissolved to form a blue solution in excess of ammonia but was insoluble in excess of sodium hydroxide. So this is totally related to the memorization or the observation. So actually that is for, because it can iron 2 is red brown, iron 2 is dirty green, and iron 3 is red brown. Copper is blue, like precipitate will remain blue. Chromium green. So only cases the green precipitate which become blue changes, that is in case of nickel. Like in these cases, the precipitate does not change a color, or even if precipitate dissolve, the solution does not change a color. Chromium is there, it is green PPT. Copper 2 is there, blue PPT, which dissolve to form a blue solution, deep blue solution. Iron 2 is there, that is dirty green PPT, so that will remain insoluble in both, it does not dissolve. That's why the correct answer is nickel. As for chromium, the precipitate is soluble in excess of sodium hydroxide, and in case of iron, the precipitate does not dissolve in both cases, and in case of copper, the precipitate will be blue in color. When aqueous sodium hydroxide is added to a solution containing manganese 2 ion, an off-white PPT is there, manganese 2 hydroxide form. The precipitate then gradually turned brown. What is the reason why the precipitate turned brown? Because the oxidation number of the manganese changes, or basically the manganese is oxidized. Like its oxidation number increases, it becomes manganese 4 oxide. The manganese hydroxide turned into manganese 4 oxide. So that's why it turned brown. So D is the right answer. Like it will become MnO2. That is manganese 4 oxide. So again, this question is related to memorization of the observation related to the precipitates. Aluminium oxide react as shown in equation. The two reactions show that aluminium oxide is, look, if a oxide can react with acid or alkali, we call amphoteric. Aluminium oxide can react with proton, it can react with hydroxide. So it means it is amphoteric oxide. That amphoteric oxide can react with both acid and alkali. Then what is the molecular formula of a compound which is given below? So Look, this is carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. So there should be 9. So all have 9. Then we can count hydrogen. This will have how many hydrogen? CH3, 3 hydrogen. This will have 1, 2, 3. So 1 hydrogen. This will have 1 hydrogen. This will have 1 hydrogen. This will have 2 hydrogen. Because carbon form maximum form 4 bond. And this is 1 hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What I missed here? 1. Oh, this is a benzene ring. Sorry, I thought it was a cyclic. This is a blunder I made. This is a benzene ring. Benzene ring, the formula for benzene is C6 and H6. I thought it was a cyclic alkane. So this carbon we already identified about the hydrogen. So this will not, because this is removed. This will have 1 hydrogen. 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 So and this does not have. These two only carbon atoms will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So C5, C9, H10, and O will be the right answer. Is it clear? Question 6. Because the benzene ring is C6H6. But when I was writing H2 there, I was considering them as a cyclic compound. Then when excess of bromine react with the benzene in the presence of UV, the products are given below. So it becomes cyclic alkane. This type of a reaction occur for alkene. Whenever the reaction of the alkene are the reaction of benzene ring, so here all the bromine are added, like a benzene ring converted into a cyclic alkane. So how a benzene ring can, and in the question how you can identify, as I mentioned, when using excess of bromine react with in the presence of UV. So what is the purpose of UV? Ultraviolet light produce free radicals. So they gave you the hint in the question that ultraviolet cause a homolytic bond breaking, and then the reaction will proceed and whole benzene ring will turn into cyclic halogen alkane. So what type of reaction occur? So it should be free radical. Why free radical? Because UV light is there, it will always produce free radical. Then whether it is addition or substitution, you can see all the bromine are added. Like if it was a substitution, hydrogen only replaced by bromine, but like only one of them will be replaced. But here what happened? All of them the bond break down. So that's why it is free radical addition reaction. Like only one product will be formed when you have a benzene ring reacted with bromine molecule. So only one product is there. Whenever one product, it means the reaction is known as addition. Is it clear, this question? Phenol is C6H5OH, which is having a dissociation constant of 1.2 in 8 into 10 power minus 10. What is the pH of 0.1 mole solution of phenol? So how to work out the pH? First, Ka is there, so it means it is acid. It has tendency to donate proton. So dissociation constant, basically when we have a phenol C6H5OH, it will dissociate into C6H5O and H plus. And when we write the Ka, so that is the product divided by reactant. So concentration of C6H5O, concentration of hydrogen ion divided by concentration of C6H5OH. because for weak acids we consider, like in the beginning, if we have 1.25 and exponent minus 10, sorry, zero point 0.1 is there, because what is the pH of 0.1 mole per. So if the concentration is zero point 0.1 here, this will be initially 0 and 0. At equilibrium, this will be x, x, and this will be 0 0.1 minus x. So this will be x, and hydrogen also x, and this is 0 0.1 minus x equal to k. And k is given 1.2, 1.28 into 10 to the power minus 10. X multiplied by x is x squared divided by, and we neglect because we say x is very small, so 0 0.1 minus x is approximately equal to 0 0.1. So this will be multiplied. So 1.28 into 10 to the power minus 10 times 0 0.1. We'll take a root to get the value of x, and the value of x represent the hydrogen ion concentration, because x shows the amount of hydrogen. And after getting the h, the hydrogen ion, we'll use the formula pH is equals to minus log of hydrogen ion concentration. So when we substitute the values, it will come out as 5.45, or B will be the right answer. Is it clear, Hashim, how we work out the pH of the solution? So it is related to, yeah, it's a weak acid. And it is obvious because look, whenever K is given, it is obvious it is a weak acid. Even C and D can never be an answer, because K is not for base, K is for. So whenever dissociation, because for strong acid we don't write Ka, as they have infinite value of a Ka, because they ionize completely. Then phenylamine is a weak base. The equilibrium constant for this reaction is 5 into 10 to the power minus 10. What is the concentration of OH ion in mole per dm cube in 0.1? Oh, so it's a weak. So same thing. So weak base, that equilibrium constant is actually Kb. And water is a liquid, so we don't have to include the concentration, only aqueous one, because water concentration does not change. It's a liquid, only aqueous concentration changes. So when we write, because it's a heterogeneous equilibrium, so we don't include solid or liquid. So Kc or Kb, I can say it's a base. So it will be C6 H5NH3 OH divided by C6 H5NH2. So in the beginning, we have a concentration, so same way, the similar question. Like 0 0.1 here, this will be initially 0 and 0. If this is x and x, this will be 0 0.1 minus x. So we have the Kb, this is actually the value for Kb, which is 5 into 10 to the power minus 10. This will be x divided by 0 0.1 minus x. And then we will neglect, because x is very small for weak base or weak acid, then 5 into 10 to the power minus 10 times 0 0.1, and take a root, under root, to get the value for x. And the value of x is actually the concentration of OH ion, which is 7.1 into 10 to the power minus 6. Is it clear, this question? So for bases we write Kb, for acids we write Ka, dissociation constant. An organic compound X reacted with bromine water to give white PPT. So the substance which is giving, and then X gave a deep blue solution with aqueous ammonia, aqueous solution of copper. So means there should be amine should be there, because with amine, if amine group is present, it will give the solution, the colored solution will be there, as the ligand will exchange, and it reacted with a bromine. So it should be and give a white precipitate. So it should be phenol. Phenol means OH group should be attached with the benzene ring. And deep blue solution, so amine group should also be there. So which one is a benzene ring? So A and B cannot be an answer because A and B, when we add bromine, it should decolorize the bromine. As there is a double bond, bromine will be added, so it will be decolorized bromine. But as they mentioned, it is giving a white precipitate. It means OH is there, like phenol is there. So either C can be an answer or D. But why D cannot be an answer? Because aqueous solution, they can like ligand water or ammonia or amine. These are the ligands which have lone pair on them. So as a result of this lone pair, it can form a dative bonding with a metal ion. So C is the right answer. Is it clear? Question 10. Then which of these compounds cannot form amide? Amide can be formed when ethynyl chloride. So which of these compounds cannot form an amide? Amide means there should be C double bonded with O and NH group is there. That is result like that is amide. So when we check the option, ammonia can react with ethynyl chloride to form amide. Alkyl amines can also react with ethynyl chloride. This hydrogen will be replaced and it can form amide. But here you can see nitrogen is already bonded with the 3 carbon chains like CH2, CH3, then there is CH3 and CH3. So this there is no hydrogen because when they form amide, like the hydrogen will be replaced by that C double bonded with O. That's how they form amide. So or rest all of them because they can replace it can replace one hydrogen, this can replace one hydrogen, this can also replace one. So this is normal amine, this is primary amine, this one is secondary. But tertiary amine cannot form amides. Why? Because the hydrogen is not there, which can be replaced by the C double bonded with O group. So D cannot form an amide. In question 12, what is the minimum volume in cm cube oxygen needed for a complete combustion of 10 cm cube of hexane gas? So first, the important thing, you should write a balance equation. So C6H14. For a complete combustion, it gives carbon dioxide and water. So CO2 plus H2O. So 6 carbon, 14. So they will put 7, 14. And oxygen to balance 6 multiplied by 2, 12 plus 7, so 19. So here we need 19 here. So 9.5 multiplied by 2 will be 19. So what is the ratio? Ratio of the moles is same as the ratio of the volume. So ratio of the mole is 1 is to 9.5. So if we have 10 cm cube, then this will be x. We cross multiply. So x is equals to 95 cm cube. So B will be the right answer. So the important thing, because the important thing was the balance equation. If we know the balance equation, we can directly write the answer. Then what mass of water in gram produced during a complete combustion of 0.002 moles of octane? Again, the same thing, we are burning octane, but we should know the balance equation, because without knowing a balance equation, you cannot work out how many moles of water will be there. So it will be C8H18, octane is there, petrol basically, burned in the presence of oxygen, gives carbon dioxide and water. So 8 carbon, so we put 8 carbon. So 18 hydrogen, 9 multiplied by 2, 18. And then oxygen, 8 multiplied by 2, 16 plus 9, so 25. So here it will be 12.5. So ratio between octane and the water is 1 is to 9. So 1 is to 9 is there. If we have 0.002 moles, this will be x. Cross multiply. So 0.002 times 9 will give us the mass, but we will give us the moles, and but we need the mass. So after getting the moles 0.009, so 0.002 times 9 will give us the moles, but we need the mass in gram. So moles multiplied by molar mass, so we'll multiply it by 18 as well. So this will give us 0.34324. So C will be the right answer. In question 14, which is the most important advantage of combinatorial chemistry over traditional method? Basically, like we can make different samples of a drug in a short time. That is the main advantage. So many more compounds can be made in a given time. Like this is a machine device system, like mechanism. So here in test tube 1 we mix sample like substance A and B. In test tube 2 we mix A and C. Test tube C we mix A and D, and so on. So like lot of combinations can be set up in a short time, in a given time. So many more compounds can be made in a given time. That is the advantage of combinatorial chemistry. So linalool is an organic liquid that is immiscible with water and can decompose below its boiling temperature. So the substance which can decompose its boiling temperature, so what we do, like if we try to heat them, they will decompose into other product. So what normally we do for this or such type of compounds, so we normally use steam distillation. Like the steam, the vapors will, when we want to separate them from the mixture, instead of heating the mixture, otherwise when we heat the mixture this compound might decompose. So what we do, we use a steam distillation. We put like steam is produced, that steam vaporize this, and the sample will rise and condenses out. So lavender flowers and the stalks are crushed and mixed with water. It is extracted from lavender flowers and stalks. Which is the correct order of practical technique to extract linalool from the mixture? So how we can extract? We'll use steam distillation, then using a separating funnel, because as I mentioned it is immiscible with water. So first when we, what we do, like we have a mixture here, we vaporize, use steam will vaporize the sample. So we'll have, when condensation occur, we'll have two layers. One will be water, another one will be linalool. And then we will use a separating funnel. We separate the aqueous and the organic layer, and we can also use drying and decanting just to remove the drying. How drying is done? By adding a drying agent and then decant to remove the drying agent. So C will be the right answer. Is it clear? Question 15. So steam distillation is always used for compounds which can decompose on heating before their boiling point. Like before they vaporize, they turn into another substance. So in methanol, oxygen fuel cell, methanol is, so whenever, like example, we have fuel cell, hydrogen or methanol, ethanol, so they are all oxidized. And where oxidation happen, oxidation is a loss of electron, and electron always transfer, always in any kind of fuel cell, hydrogen fuel cell, methanol, ethanol, electron always transfer from the anode to cathode. With reference to movement of electron, because anode is in terms of loss of oxidation always happen at anode, that's why we call this as anode. But in terms of movement of electron, this is a negative terminal, this is a positive terminal in terms of movement of electron. So Methanol loses electron, oxidize, and these electron transfer. So A is the right answer. Question 17. Copper 2 ions oxidize titanium 2 ions. The half equations are shown. The electrode potential of a cell is given. Standard electrode potential for half equation 1 is. So how to work out the electrode potential? So we have the formula oxidation minus reduction. Like electrode potential of a cell is reduction minus oxidation. Redox is there. Redox reaction. So it's reduction minus oxidation. So electrode potential of a cell, that is 0.71. So this is 0.71. As I mentioned, copper 2 ions are copper 2 ion oxidized titanium. So copper 2 ions are reduced and titanium is oxidized because the oxidized titanium, so oxidation happened for titanium, we don't know that is unknown voltage, oxidation voltage is unknown, and for reduction that is 0.34. So this one is equals to 0.34. So when we work out, this will move other side, the electrode potential for oxidation, and this is 0.34 minus 0.71. When we simplify, it will give us minus 0.37. So it means this voltage is actually minus 0.37. So A will be the right answer. Is it clear, this question? So always it is redox. Just remember from redox, reduction minus oxidation. This question is about the following reactions. The relevant standard electrode potentials are shown. Which reactions are thermodynamically feasible under standard conditions? So if we get a positive answer, it means they are feasible. If we get a negative answer, it means they are not feasible. So which reactions are thermodynamically feasible? So we can check for each. So when we check for P, so iron, there is a reaction for iron 3 and bromine. So when they are reacting with each other, when bromine and iron 2 is actually, because look, there are two ways to solve this question. One is you try to figure out that what is happening, and then when you try to figure out, that time you have to take signs also, like which direction you are considering. Or the second one is a simple electrode potential of a cell is reduction minus oxidation. So the one which is having a higher electrode potential, that reduction happen, the other one oxidation will occur. So when we have, because if we have a reaction like iron, here iron 2 is there, the one of the equation, the first one is in a bromine, and we want to identify whether this reaction will occur. So again, reduction minus oxidation. So in this case, bromine, because bromine is Br2. So according to this equation, bromine should be, if this is a high voltage, when we compare the two, so this should reduction happen and this one oxidation happen according to the voltage is given. But when we work out like whether it is thermodynamically feasible, so what is the formula? That is red minus ox. So 1.09 minus 0.77. So we'll get a positive answer. So if we are getting a positive answer, it means this reaction is thermodynamically feasible. So this P can occur. So any option with a P is right. So A and B are only. Then when we check Q for iron and iodine, so here in terms of this equation, this is a high voltage. So this one reduction happened, like iron 3 should be reduced and this should be oxidized. So when we, but here according to the question, according to the voltages, iron 3 should be reduced and iodine should be oxidized. But what is happening in the equation, as you can see what happened in the equation, iron, in terms of the equation, what is happening, iron 2 is it's like an opposite one, a reversible is happening. So if iron 2 converted into iron 3, if iron 2 is changing into iron 3, means according to this, so this will be negative. Even I can work out like iodine molecule, if I use the equation, so according to the equation, how to identify if iodine molecule converting to iodine, so what happening, it is a gain of electrons, so this is a reduction. So this will be reduction, so this will be 0.54, like 0.54 minus oxidation, iron 3 become iron 2, so that's a loss of electrons, oxidation, and that voltage is 0.77, so 0.77. When I substitute, I'll get a negative answer. It means this reaction is not feasible according to what equation is written. Is it clear? So when you check, even either A can be an answer or B, and Q is cannot be an answer, so we are left with only B. We can check S, as you can see, iron 3 become iron 2 and iodide become iodine. So reduction happened for iron. So if the voltage for reduction is 0.7 minus oxidation is uh, for iodine 0.54. So when we substitute, we'll get a positive answer. It means this reaction is thermodynamically feasible. In a titration experiment was used to find the percentage of iron in iron tablets, a volume measured uncertainty for each. What is the total percentage uncertainty to 2 decimal places? So what we did, the volume used and measured uncertainty for each. So for a burette, because a burette is always, whenever we read a burette, we read the initial volume and we read the final volume. So the uncertainty of the burette, each reading is uncertainty is 0.05, but twice if we read, so it will be double, so 0.05 times 2 and divide by value recorded 21.8 multiplied by 100. And but if pipette is, you only use the fixed volume, one time we just fill up and we read one time the volume, so it's not multiplied by 2. So when we substitute, so C will be the right answer. So burette, because it is used twice to measure the volume, so that's why the total uncertainty will be always multiplied by 2. Then sulfuryl chloride SO2Cl2 react with the water to give a mixture of sulfuric acid H2SO4 and hydrochloric acid. How many moles of sodium hydroxide are needed to neutralize the solution form by adding 1 mole of. So first we have to write a balance equation. SO2Cl2 mixed with water to give a mixture of H2SO4 plus HCl. So first we start to balance with oxygen, like here so can put 2 chlorine is balanced, sulfur is 1 already balanced, hydrogen, if I put 2 hydrogen is balanced, 4 hydrogen are there, 4 oxygen are there, 1 sulfur and 2 chlorine. So equation is balanced. So 1 mole of sulfuryl chloride, how many moles of acid are produced? 1 mole of sulfuric acid and 2 moles of HCl. Then what is the equation for reaction between sulfuric acid and sodium hydroxide and sulfuric acid and HCl? So if we have sulfuric acid H2SO4, when we try to write a balance equation for reaction between them, it gives sodium sulfate plus water. So 2 moles of sodium hydroxide are needed to react with 1 mole of sulfuric acid. And the relation between HCl and sodium hydroxide, the ratio between them is 1:1, so it will produce 1 mole of sodium chloride. So for 1 mole of sulfuric acid, we need 2 moles of sodium hydroxide. And for 1 mole of HCl, we need 2 moles of sodium. But because in the question we have 2 moles, so we need 2 moles of sodium hydroxide. So what are the total number of moles of sodium hydroxide needed? 2 moles will react with 2 moles of NaOH will react with sodium hydroxide, and 2 moles of NaOH will react with HCl. So total number of the moles which we need equals to 4 moles. Is it clear?